Students, today let us see lexical analyzer, which is the first phase of compiler, right? So lexical analysis. Lexical analyzers are divided into cascade of two processes. Scanning consists of the simple process that do not require tokenization of the input, such as deletion of comments and compaction of consecutive whitespace characters into one. Lexical analysis proper is a more complex portion where the scanner produces the sequence of tokens as output. Interactions between the lexical analyzer and the parser is done using the get next token command. It causes the lexical analyzer to read characters from its input until it can identify the next lexeme and produce for it the next token, which it returns to the parser. Let us see the basic block diagram of lexical analyzer. So the source program is given as input to the first phase of the first phase of the compiler, that is lexical analyzer. So each and every token will be given as input to the parser. Meanwhile, parser will check for the syntax and it will check for the get next token, right? And if any identifiers are there, it will be stored in the symbol table. After the syntax is checked by the parser, the output will be given to the semantic analysis to check for the data type. Why to separate lexical analysis and parsing? It is the simplicity of design for improving the compiler efficiency and for enhancing the compiler portability. Now, let us see the tokens, patterns, and lexemes. A token is a path, a token name, and an optional attribute value. A pattern is a description of the form that the lexemes of a token may take. A lexeme is a sequence of characters in the source program that matches the pattern for a token. The example is as given below. Now, examples of tokens. So, if you find if, right, that is I and if, right, the lexeme is if, so it is a keyword if. Similarly, else, ELSC. So for comparison, you have the relational operator. So for ID, it is letter followed by letter or digit. For number, it is any numeric constant. So the digit will be from 0 to 9 and it will have even decimal value and the exponential value. Literal, it is anything but surrounded by. Okay, so it is the core dumped. Now we'll see the attributes of token. If more than one lexeme can match the pattern for a token, the scanner must indicate the actual lexeme that matched. This information is given using an attribute associated with the token. For example, E is equal to MC square. So M is an identifier, right? And then E is an identifier, equal is an assignment operator, right? Then we have multiplication operator, then C is an identifier, then you have the power symbol, which is an operator, then we have the constant number. Lexical errors. Some errors are out of power of lexical analyzer to recognize. Okay. However, it may be able to recognize errors like D equal to 2R. Such errors are recognized when no pattern for tokens matches a character sequence. The various error recovery actions are panic mode. Successive characters are ignored until we reach to a well-formed token. The second error recovery action is delete one character from the remaining input. The third one is insert a missing character into the remaining input. Fourth one, replace a character by another character. The last one is transpose to adjacent characters. Thank you, students.